More than 9 decades of serving the nation. Central Board of Irrigation and Power.
SCADA system is a term used for a type of automation in which multiple devices are controlled from a single location. मैं इस पे फिर भी आऊंगा अभी आगे भी. SCADA, what it is by name, this is the explanation: supervisory control and data acquisition. इसको आप ऐसे मान के चलिए, data acquisition, so it's a normal English term, is acquiring data, so getting data to a location. Why do we need data? Because you want to control that process, whatever the process is, we need to control. And this, you know, the normal terminology says you cannot control anything unless you know what it is. So unless you measure it, unless you monitor it, there's no way you can control it. So that is why control is extremely important part of this whole scheme. Bacha ek word, supervisory. This mixing Hindi English will not cause any trouble. Okay. So the word supervisory is equally important in this context, because this says this automation on this process is not the automation which you know from many other type of industries, where the machine is automated to the extent that it will take the input, give the output, everything is automated. That is not the case here. We talk of, as an example, those self-driven cars. We would have read the news about this, na? Tesla and so many other companies, Apple, etc. They are trying to make a car which can drive itself. So that is almost total automation. That total automation. But SCADA requires an operator necessarily. So the word supervisory is to identify that you require an operator. Somebody is required to supervise this automation. So that also says that the word automation itself is wrong in this particular case. It is not a full automation. It is machine being utilized to run a process, but requiring a human being to run that machine. Always bear in mind, SCADA necessarily means that there has to be an operator. It's not total automation. Again, battery. नहीं वो तो करने के बाद मैं यहाँ से भी कर लो.
No sir, actually
ऑन है कि नहीं नहीं तो आपको ये
अच्छा सर ये
इसका ऑन ऑफ का बहुत एक है
सर ऑन है.
हाँ चला. Okay. Since we are talking about power system, then this term will also be used together with SCADA. It's a separate part. It is not part of SCADA. But usually SCADA goes together with EMS or energy management system. Depending on time available, I might talk a bit about some EMS functions, but that is not the topic of the day today. Something you'll find in these slides on this also. So take your time, read through it. And rest everything is Google Baba. You can find a lot of information there. Okay. Energy management system. This is a set of software which sit on top of the SCADA system. The EMS will not work unless SCADA is there. So SCADA is the basic layer. It's like the flooring, and on that you can put a carpet. Really SCADA, and then on top of that EMS. On that you can put other furniture, so there will be other layers also, but I'm talking just of these two layers. Power system has got three components you know very well. So in all three, SCADA is equally applicable, but historically it gets a different name. We do not call it SCADA. SCADA is the basic technology, but when it is used in the transmission system, it will be called as load dispatch control system or load dispatch center, LDC. In distribution, combined with some energy management functions, it becomes distribution management system, DMS. And for generation, we use the term as a plant control system. Now, SCADA, the data will come from the end devices, the last device which needs to be monitored or even controlled both ways. So that could be at a distance already. So starting from there, SCADA applies to everything right up to the control room. So the equipment system, including the operator, everything in the control room is definitely part of SCADA. But also the mechanism which you utilize to get data from far-flung locations. Even that is part of SCADA from my point of view. But since you will be working in that industry, and if you want to order a SCADA system, a tender has to be issued or something, then only the control room part of the system and the equipment associated with that, that would be part of the tender. The equipment outside in the field, that is usually part of that field equipment itself. So although everything, technically everything is part of SCADA, because I'm getting data from the endmost device. So that is part of SCADA. But if I'm tendering, if I'm going to order a new SCADA, I limit myself to whatever is there in the control room part only. Everything else goes in as separate sections, separate packages. So both these, either the total system, this is one explanation for SCADA, complete from end to end, or else just the control room part of the system. So you need to identify the context and accordingly decide what SCADA we are talking.
Basic question, how will you explain the relation between programmable logic controller and SCADA?
And OVI. That programmable logic controller or PLC is one of the devices which can be attached to SCADA system. It is not SCADA, but it does some function on its own, but I can connect it to SCADA because the device has got its own data available, which would be useful to SCADA also. So this would be somewhere a part of the data acquisition. When I talk to SCADA as data acquisition, in that PLC is also one of the devices which can supply data to SCADA. SCADA applications at this point, where do I apply SCADA? Where can I use SCADA? These are the general conditions to identify it. The process should be largely continuous. SCADA is only applied to processes which run continuously or almost continuously. Like power system also, there could be a blackout, so maybe for some hours nothing is running. But our expectation is the power system will run forever. So it is a continuous process from my point of view, so SCADA can be applied to it. But processes like a bottling plant, Coca-Cola ho, chahe Limca ho, somewhere, no, these bottling plants, they are not a part of SCADA system. They cannot use SCADA because these are batch processing processes. Sorry, these are batch processes. I think it'll be simpler to give you example of medicines manufactured. Pills are manufactured. So how do we do it? There would be a big vessel in which the ingredients or the chemicals required for that medicine would be put together, mixed, and whatever chemical process is required to convert it to the final medicine, and that will be carried out, heating, cooling, whatever. And then this is one batch of medicine which is there. Now from here, the rest is packaging of this into either capsules or in that bubble packs, whichever way. So, and once this one lot is over, you have to start all over again. New mixing has to be done. So this is called batch processing, different from continuous process. And in general, SCADA is not applicable to batch processes. It is meant for continuous processes. The process is expected to be spread out and spread over a long area. You know very well, power system of the three components we talked about: generation, transmission, distribution. Start with transmission. It covers a huge region. If we talk of this country itself, you know, finally transmission is end to end from the southernmost point of the country to the northernmost point. Everything is covered through transmission system. So it so happens that just to manage this system, we have made 5 regional load dispatch centers. On that, there is one national load dispatch center. Every state has got its own state load dispatch center. But this is administrative issues. Finally, the whole transmission system is being managed through SCADA system at multiple levels. So it's a huge area we are discussing. So physically spread out area. But now come to the next layer, distribution system. Instead of talking about Gurgaon, let me talk of Delhi, our neighboring location. It's a big city, a bigger territory, but still it is limited in certain area. But that area is also pretty large. We have got around 4 entities in Delhi handling power. Each entity would be covering approximately 1/3 of the city in that range, which itself is pretty large. So again, physically spread out. So that distribution system can be managed with SCADA. Can be, but it should be. I will put it the other way around. We need to use SCADA if we want to manage it. Now come to the even smaller part, which is power generation. What example should I take? Let's say hydropower. It starts where the dam, where the water is stored. So from the dam it starts, and then there would be the power station itself with its substation, etc. And finally the discharge of the water which has been used up. So the total power station starts from the dam and ends at the tail race. This distance could be as small as a couple of kilometers, or it may be as large as something like 10-12 kilometers, depending on the terrain, what kind of slopes are available, etc. If we talk of thermal power stations, coal-fired thermal power stations, so the coal storage area is there, stocks are kept, and then conveyor belt would be there to bring the coal to the boiler. From the boiler, steam has to be taken to the turbine location. Again, we are talking of a big area of the order of some 3, 4, 5, 7 kilometers. So it's a large area, although it is smaller than the other two varieties I talked about. So distribution or transmission are larger, but still a power station is also pretty large. Why I am emphasizing on that distance issue is because we cannot have people running from place to place trying to gather information which is needed. That is where SCADA excels. My information would be coming automatically to the control room. And it would be the most immediate information, latest information. Otherwise, I have seen that period also when we didn't have SCADA system. We used to have telephone system only. Old landline type of special type of telephones were there in the load dispatch center. So every hour or so, the operator would lift the phone, individually call up every location, every substation. भाई आज का data क्या है अभी बता दो. So that fellow will read out the meters on his table and give that data. This person will have to note it in the register. Now what happens? This data is at least 1.5 hour old. It is not the latest data. So I am using this data to manage my control philosophy. Our system fluctuates so fast. 1.5 hour. I'm really not managing it. I'm just managing myself, not the power system. काम करना है, हमने कर दिया, खत्म हो गया. It really, just to give an example, please don't quote me, and I'm not naming any party. There was a power station where I had gone for some other work. I found the shift engineer. He told me, morning में जब shift शुरू होता है तो हम आते हैं, आके वो डेटा रजिस्टर निकाला, तो जो class 4 employee है उसको पकड़ा दिया. He goes to the control room, note down the reading from every meter first thing in the morning. Then when the shift ends, once again the same procedure is followed. So there you have 2 readings only. Beginning of the shift, end of the shift. And shift is how much? 8 hours. Then he says, before going home, I sit with that register. I have a format of form to fill up. First reading, last reading, and then I estimate the readings in between. Because I'm supposed to give half hourly or hourly readings in that form. So I estimate how the readings would have been. And then that form once completed, I fax it to the head office for their management purposes.
So it was without SCADA.
No SCADA.
No SCADA.
Yeah, this is the old, we were discussing with that party how to put up SCADA there. In that process, we came across this example. So the immediate concern from our side was like, if your data, first of all, is 8 hours old already. And in that in between, you are just estimating values. What is the accuracy of that data? And result my head office use. This was just a process. I have to send it to head office. I have sent it. My job done. But what is the use of this data? Head office wanted it for what purpose? They had to identify, are the machines running normally? Is there some anomaly, abnormality, something in the system? Do they need to intervene? And then they have to report it further to government. How's the power station doing? The regulatory authorities need to be informed. I think everything goes for a toss because the starting point itself is estimated. So importance of SCADA comes there. Data is available automatically into the system, and the report created from this data is bound to be accurate. So it can be used for whatever purposes that data is required. So back to my statement in the beginning, if I don't have data, I cannot control. So requires common monitoring and control. But the process is such that I have to sit at one place and control the whole process. There is no point by having a transmission system, let's say my substation in Uri at that end, and another one I put at Rameshwaram. Now these substations, if they are not connected by any means, then they are just operating on their own. What happens at one end? He may overload the system, and therefore the system might simply lose frequency.
Saying what synchronization.
Synchronization, see, right now the whole country is running on 50 hertz plus minus 0.2 or something right now. With that, you know how stable the supply is. It is only possible with SCADA. If it was done manually, then I have seen those days also when frequency used to go down to 42 hertz or go up to about 54, 55 hertz, and voltage from 100 volts in my the normal household socket, from 100 volt to about 300 volt, 360 volt actually I measured. This personally measured by me in my first job. Can we live with this condition? Today we can't imagine. We have gone through that process because we didn't have any alternative.
That time technology is not so much smart and
See, we are dependent on what we have. If we didn't have any other method of working, so we're working with that system which was there. I can't blame those guys.
So by using SCADA, we can bring different stations on a common platform. And
Right, exactly,
monitor them and
exactly.
Operate them.
Yes.
simultaneously.
This process is right now working, and that is how we're able to have a stable power system running. In spite of having so many generating plants in this whole system, and for example, for this region, we might be importing power all the way from Assam.
Yes, sir. And I think we are.
Right. There is a HVDC line. Only recently they have commissioned that line. That brings a whole lot of power up to about some 2,000 to 4,000 megawatt power is brought all the way from Assam to this place. And we are still able to operate stably in spite of all this. That is SCADA system. Okay.
Sir, we are also managing power, like where power is in excess, like northeast state, load is not there that much to consume that. So we are taking the power to Delhi, cities like Delhi.
Right.
Load consumption is more.
Right. Okay.
SCADA is helpful in this.
The whole power system is first place designed for this kind of transfer of power because it's just not feasible or manageable that every small area will have its own generation. If we were able to do that, we will be talking about microgrids, self-sufficient thing.
interregional transmission lines.
See, transmission lines are useful because we need to transmit power. If we did not have that requirement, I say Gurgaon by itself, I set up one power station in Gurgaon and supply only to Gurgaon. And say my power is sufficient to supply to whole of Gurgaon. Number one, it may not be economical for me to do so. That power station, what is the fuel I'm going to use for it? Fuel has to come from somewhere. Then the size of the power plant which I set up will not be as big or therefore so efficient as a super thermal station which I can set up in say Jharkhand, where coal is available just next door. So they can afford to build huge power stations which can produce power at a very cheap rate And then it's only question of can we transmit it? How can we transmit
Yes,
it?
there are many techno-economical reasons for that.
Right, lots of methods are there, and questions are there, answers are there to manage this. We are simply talking about that there is a power system which requires power to be shifted from one place to another.
We need a
It is
system.
all planned. It's not unplanned. It is planned transfer of power in general. But with SCADA, we can also manage the unplanned or unscheduled changes which may occur because of some problem in one area.